Welcome back, guys. In this lecture, I'm going to start from question number 36 of GRE subject test preparation practice book for mathematics. And I will go till question number 14. So question number 36 says that let S be a bounded subset of the real line. So it is some sort of bounded subset of real line, which is named as S. That is connected. It means it has, let's say, one part. It's not divided into different parts. It is connected and has more than one point. It means that it is not a single point. It has many points. And f be a continuous real valued function defined on that set S, which of the following statements must be true. So look at the first statement. It says that S is a closed interval. In the statement, it is given that S is bounded and connected. So if I take real line, if I take an interval from A to B, let's say this is open interval, this is bounded because it has some sort of upper bound. Because if you take an interval from 2 to 5, then it has some sort of upper bound, let's say 5 or 6 or 7, and all the elements of the set are below that. So it is not necessarily a closed interval. It can be an open interval because open interval is connected and bounded. I'm not taking interval from some fixed point to infinity. I'm taking from, let's say, some A to some B. Okay. So first statement is not true. It can be true, but it is not true in general. So you can just see the options and you can see I can exclude E and I can exclude C because both of these involve first option. So now it says that f of S has a maximum value. So for this, let me take an example. Of the function 10x. The question is this function continuous? The answer is yes as well as no, depends upon what your domain is. So if I'm taking my domain from negative pi by 2 to pi by 2, excluding pi by 2 and negative pi by 2, because at pi by 2, it's infinity, and negative pi by 2, it's negative infinity. So I'm just excluding these, hence my function is continuous. Obviously, it is not, let's say, Lipschitz continuous near pi by 2. It's not uniformly continuous or whatever, but it is continuous. So the graph of the function, now if I draw this line at pi by 2, and then the graph of 10x looks like this. So it goes to positive infinity here, and it goes to negative infinity here. So it is not going to be below some value so that I can define, okay, what's going to be the maximum value of this function. But it is going continuously because I'm not defining the function at pi by 2, so I'm good to go. So in general, second option is not true. So you can exclude now D. Now you are left with A or B. So this is a good practice. Like if you're not sure about the third statement, let's say, then you can choose either A or B. This will give you more chances for your answer to be correct. Okay. So the set f of S has a least upper bound. So the first thing is that does it have an upper bound? So its upper bound goes to plus infinity. And what is the least of that upper bound? It's again plus infinity. So we say that the upper bound does not exist. So we simply exclude this option as well. Hence, the correct option is A, because upper bound should be a finite value. Upper bound cannot be infinity. It can be, but we say that, okay, it does not exist. Otherwise, we can say the upper bound is plus infinity and the least upper bound is plus infinity, but existence of an upper bound is a problem. Okay, because we want some sort of upper bound that is defined and should be finite. So we are going to exclude this option, hence none of these statements is true in general. Let's go ahead. Okay, so in this one, we have to find out the maximum value of this function subject to this constraint. So when you are going to find out the maximum value of some function, given some sort of constraint or the restriction that you have, the most common method that we apply is Lagrange multipliers. So here we'll apply Lagrange multipliers. And the idea is really simple, because when you have some sort of function, let's say this function is let's say a plane in 3D or whatever. If you are going to project it down in let's say two-dimensional space, it would be a line. So let me give you the idea of this thing. So you have some projections of those planes on, let's say, XY plane, and you are going to find out what's going to be the maximum value on this circle, on this ellipse. But when you project that ellipse down, it becomes a circle. So let's say this is my circle, and this is my circle. So these are some sort of circles. Now what do I need to do? I need to find a point that gives me maximum. What I'm going to do, let's say this point is the maximum, then I can draw some sort of gradient f and gradient, let's say, g. They will be either in the same direction or opposite direction, doesn't matter, but one would be the linear combination of other. Mostly they are in the same direction, so I'm going maybe in opposite direction. This is my grade g. It depends. It depends upon whatever the value of lambda is you're taking. Mostly, I think it's going to be positive. So the idea is grade f is lambda times grade g. So this will give you maybe a system, and it will involve, let's say, n+1 variables, and it will give you n equations. But if we have n+1 variables and n+1 equations, we are good to go. Another equation that we take is this g, and this is our f. So another equation is g equals 0. So solving this system will give us the value of lambda, x, y, and z. We'll use the value of x, y, z and put in the function. Maybe we get multiple values, and we'll check that which value gives us the maximum. That's it. So this is the idea behind this, and we'll apply this idea. So let's see what happens. So grade, what is f? Let me write the function f. X minus 3y plus 2z, x minus 3y plus 2z equals lambda. Grade g is x square plus y square plus z square, and you can take 9 on the other side, that becomes minus 9. What is grade? So grade is simply, I will get a vector, and I have to differentiate this function with respect to x partially. So if I differentiate this function with respect to x, I'll get simply 1, because the derivative of x is 1 with respect to x, and the derivative of rest of the terms are 0 because they don't involve x and they are considered to be constants. And the derivative with respect to y is minus 3, derivative with respect to z is plus 2 equals lambda, and the derivative of with respect to x is 2x, with respect to y is 2y, with respect to z is 2z. So I need to just simplify this, and maybe I'll get 3 equations, but I have 4 variables. The variables are x, y, z, and lambda, and I have another equation to find out these all the things. So if I'm going to equate these all terms, the first one with the first one multiplying lambda, I'll get 2x lambda equals 1. This gives me the value of x 1 over 2 lambda. And you might be thinking why I'm going to find out the value of x in terms of lambda. It will be clear in a moment. And 2y lambda is -3. This gives me the value of y to be -3 by 2 lambda. And 2z lambda is equal to 2. This gives me z equals 1 over lambda. So I will take these all the values and I'll substitute in this function. G equals 0, or I have this g equals 0. So I'll substitute these in. X square plus y square plus z square equals 9. So the value of x is this, the value of y is this, and the value of z is this. I will just substitute and I'll see what happens. So x is 1 over 2 lambda. When I square it, becomes 1 over 4 lambda square. Y is 9 over 4 lambda square. Z is 1 over lambda square equals 9. So you can see that when I substitute the value of x, y, and z, now I have an equation only in terms of lambda. I'll solve this and see that what is going to be the value of lambda. So my LCM is going to be 4 lambda square. This becomes 1 plus 9 plus 4. And when I cross multiply here, this becomes 36 lambda square, and the right hand side becomes 14. And now my lambda square is 14 divided by 36. When I take a square root on both sides, this gives me square root of 14 divided by 6, positive and negative. So I have two values of lambda. One is a positive value, one other is a negative value. I will, let's say, I'm going to check the positive value and see what happens. So from these equations, my x is 1 over 2. The value of lambda is square root of 14 divided by 6. So this gives me 3 divided by square root of 14. And the value of y is -3 over 2. The value of lambda is square root of 14 divided by 6. So 3 times, this gives me -9 over square root of 14. And the value of z is 1 over lambda, which is 1 over square root of 14 over 6, which gives me 6 over square root of 14. So I got these three values, x, y, and z, using only the positive value, not the negative value. Now I'll see that what value of the objective function, which we call f, gives from these three values. So f is x minus 3y plus 2z. Let me verify it. Yeah, it's this, x minus 3y plus 2z. So just substitute these three values of x, y, and z. So 3 over square root of 14 and -3 times this value is plus 27 over square root of 14 plus 12 over square root of 14. When we are going to simplify this thing, this will give me, okay, 42 over square root of 14. This is the value, and now you will just substitute negative value, and again you will take this negative value, you will substitute in these formulas here, you will get different values of x, y, and z. You will put in the objective function and you will get a different value, and then you will see that, okay, which value is going to be maximum of these two. But I believe is 42 divided by square root of 14 is the maximum value. You can check this by yourself, and this is our correct option. So this is Lagrange multipliers. This is a cool idea. The thing is that when you have good practice, you can do these all the things within, maybe you can do this whole question within at most 2 to 3 minutes or 5 minutes at most. But when I'm explaining here, it takes a little bit longer. Okay, So let us move ahead with question number. So we are done with, I missed question number 38. It's really a nice question. They are asking A, B linear transformations from some space, let's say R12 to R12. Null space of A has dimension 3 and the null space of B has dimension 5. D is the dimension of null space of linear transformation given by composition A composed with B or A after B. So we are required to find out the dimension of null space of A after B. So they are asking what are the possible values of D. So let me tell you, there is a theorem in linear algebra. I'm not going to prove it. I'm just going to quote it. The dimension of null space of composition of some linear transformations is at least the dimension of null space of A. What is A? A is the last transformation that you apply, because in this transformation you apply B first, then you apply A. So the last transformation is A, so it is at least the dimension of null space of A, and at most the dimension of null space of A plus dimension of null space of B. So just now you can put the values and you see that what happens. So let me do something. Okay, I don't need to do anything. I'm just going to write it here with the red pen. So dimension of null space of A composed with B is D. What is the dimension of null space of A? We saw it is 3. And what is the dimension of null space of A plus null space of B is 3 plus 5, which becomes 8. So dimension of null space of A composed with B is at least 3. It's at least 3 and at most 8. We are done. So at least 3. Is it 3? Yeah. And at most 8. Am I mistaken? A composed with B. So the correct option for this one is C, but it says that the correct option is D. I'm not sure why this happens, but this is going to be the theorem that we are going to apply. And A composed with B. So dimension 3 null space of B is dimension null space given by. Okay, we can verify this thing, or you can also verify this thing that, okay, which one of these is true. Just go and Google it. And I found this statement, and I think this is correct. You can further check what's the problem here. So null space of B is dimension 5. Okay, we're leaving it for now. You just check and see what happens. Okay, question number 39 is too simple. It says that for how many distinct values of X is the given matrix non-invertible? So let me check one thing. Okay. Okay. So we have to find out what's going to be the determinant of this matrix. So simply, since this is like upper triangular, the lower entries are 0. So the determinant is only the product of these diagonal entries. So let me name this matrix A. Determinant of A is 1 plus x, 1 plus x square, and 1 minus x. So it asks for how many distinct values of x is the matrix non-invertible. So non-invertible means its determinant is 0. So non-invertible means its determinant is 0 that I wrote. Now for how many values of x the determinant is 0, you just need to solve this and see how many answers or how many roots or how many solutions do you get. So you will see that you will set this equal to 0, you will get x is equal to -1. Set this equal to 0, you will get x is equal to 1. And set this equal to 0, you will get x plus minus I. So 1, 1, and 2. In total, these are 4 values. So the correct option is option E. Let us move towards the last question. That's a bit tricky, but like we are going to do it in a more efficient way. So it says that we have 10 lines in a plane such that no of 2 lines are parallel. It means no lines are parallel and no 3 lines have a common point. It means if you draw 3 lines, then they don't have common point. 2 lines can intersect, but not 3 at the same point. The 10 lines divide the plane into how many regions? Into how many regions? So there is a formula for that. Let me write the formula, but I'm going to justify the formula as well. N square plus n plus 2 over 2. So n is the number of lines. This is the formula that gives you that, okay, in how many regions is going to be like those 10 lines divide the plane. So you draw the lines and you see how many planes do you get. So if you substitute n is equal to 10 here, so 10 square plus 10 plus 2 over 2, you will get 112 over 2 and 56. So 56, 56. That's it. But the question is, where does this formula come from? So let me give you maybe a little hint. If you want to leave this over here, you can just go and you just memorize the formula and see what happens. Then you can answer all the questions. But what is the idea behind this? Let me discuss the idea. So if I have maybe a plane and U shows the regions. If I have no lines, then how many regions do I have? It's one region. So I have a plan. I'm going to put no line. So let's say this is my plan. And there's no line, then there is only one region. So U of 0 is 1. If I'm going to put a line, it means one line, then how many regions do I have? 2 regions, you can see. And if I put, let's say, 2 lines, obviously lines will intersect each other. It's not necessary. If I'm going to draw the line here, so this line will come and cut it here, but I'm not interested in this thing because I know that these are the lines and lines are extended towards the infinity and they will intersect each other at some point. So if I have 2 lines, you can see how many regions do I have? 1, 2, 3, 4. Very good. If I have 3 lines, 1, 2, 3, how many regions do I have? 1, 2, 3, 4, 5, 6, 7. 7 regions. I'm not going ahead. I will use only this thing to justify something. Now, the question is, what can I write this 7 as? What can I write this 4 as? What can I write this 2 as? It means I want to get some sort of equivalent representation for this. You can see that I can write this thing as U of 2 plus 3. Because what is U of 2? U of 2 is 4. And 3 is coming from here. And this gives me 7. I can write this thing as U of 1 plus 2. So 2 comes from here and U of 1 is equal to 2. So 2 plus 2 is going to be 4. And U of 1 is U of 0 plus 1. So generalizing this thing, I will get that, okay, u of n is equal to u of n minus 1 plus n. So whatever your number here is same n here, you can see 3, 3, 2, 2, 1, 1. And this number n minus 1 is 1 less than n. So you can see this 1 becomes 0, this 2 becomes 1, and this 3 becomes 2. Very good. So I have this general recurrence relationship, and with the help of this, I can do lots of things. It means I have un minus 1 equals n. I can go ahead un minus 1 less would be un minus 2 equals n minus 1. I can go up to u of 3 minus u of 2 equals 3. Sorry, u of 2 minus u of 1 equals 2. You can see from this one. And u of 1 minus u of 0 is 1. Now what am I doing? I'm going to add both sides. These are equations and you can simply add. I'm going to add not this one, not this one, but these all the equations, like these all the equations I'm going to add. You can see one thing that, okay, I have un minus 1 negative, un minus 1 positive, they are going to be cancelled. So negative, positive, negative, and there would be positive here, negative here, positive here, negative here, positive here, negative here, positive here. All of these are gone. And now I will get very simple thing, that is like un minus u of 0 is, now you have to add the things on the right hand side. So this is n minus 1, 3, 2, 1. I can reverse the order. I can write 1 plus 2 plus up to n. So every number from 1 to n. And you know very well, u of n same, u of 0 is 1, because if there are no lines, then there is one plane. And 1 plus 2 plus n would be n plus 1 divided by 2. That's the formula for the sum of natural numbers from 1 to some fixed number n. You can take one another side. Let me write with. So from here, you can take one another side, n plus 1 divided by 2 plus 1. And if you simplify, you'll get n square plus n plus 1 divided by that one, I think 2. Yeah. So this is the formula for finding the number of planes which we get when we have some sort of lines in the plane intersecting each other at a single point, and no three lines are intersecting and no lines are parallel to each other. So you can see I just applied this. So I just gave you a justification why we have this formula. And I applied this formula in this question number 40 and we got this answer. So we have done question number 40, 39. And we have a little confusion with question 38. You will check. Otherwise, tell me something in comments and we'll just make it correct. 37 is okay because we have done this and we did question number 36. So see you in the next video with more questions. So till then, goodbye.